Hi again, it's your favorite math teacher. Let's talk about the trig ratios again, but now we don't just have sine, cosine, and tangent. We have these new ones, cosecant, secant, and cotangent. You know from SOHCAHTOA that sine is opposite over hypotenuse. Well, sine links to cosecant. This is cosecant, and it's the reciprocal of sine, hypotenuse over opposite. Cosine is adjacent over hypotenuse. Well, its reciprocal is called secant. Secant is hypotenuse over adjacent. And tangent is opposite over adjacent. Its reciprocal is cotangent, adjacent over opposite. We're going to use those for solving in a right triangle. Here's a right triangle up here. You're going to be given two sides, maybe that one, maybe that one, maybe this one, maybe that one, and you're going to maybe sometimes have to find the third side. You use the Pythagorean theorem on a right triangle to find any missing side. Remember, the two legs, the opposite adjacents, are the legs. A squared plus b squared is equal to the hypotenuse squared, c squared. Well, let's look at the guided notes. So in our notes, it says to find the sine of theta for this first problem. Find the sine of theta. That's just the ratio. Here's theta. This is the hypotenuse, but that's the adjacent. So use the Pythagorean theorem and find in simplest radical form that other side. Now that other side, if you use the Pythagorean theorem, is 24. Now that you have the opposite to theta, remember theta is this Greek letter and it means the measure of that angle. 24 is opposite, 25 is hypotenuse, so the sine is 24 over 25. Does that fraction simplify? No. Does it have a radical in the denominator? No. So that's our final answer. The second problem is asking us to find cosine of theta. Here's theta. Cosine is adjacent over hypotenuse. And again, I don't have the hypotenuse. So we need to use the Pythagorean theorem to find it. The Pythagorean theorem gives us 25, I believe. 25 for the hypotenuse. And then cosine is adjacent over, adjacent over hypotenuse, which gives us 15 over 25, but this time it does reduce, and we need to divide both the numerator and denominator by 5 and make it 3/5. Now how about on the third problem? I need tangent. SOHCAHTOA says that's opposite over adjacent. I need to find the adjacent side here. Use the Pythagorean theorem. Radical 7 squared plus x squared equals 4 squared, and you get that the adjacent side is 3. That means that tangent, opposite over adjacent, gives us radical 7, pretend that's a 7, over 3. Check your fraction. Does the radical simplify? Does the fraction simplify? Is there a radical in the denominator? No to all of those. That means that's my final answer. On number 4, cosecant. Look back in your notes if you need to. Cosecant is defined as the opposite of sine. That is, here's sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. We have both of those measures this time, so I can just write hypotenuse over opposite. It doesn't simplify, and there's my answer. How about secant? Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. That means that secant is hypotenuse over adjacent. So again, we need to use the Pythagorean theorem and find the adjacent side. You'll find that that's 16 when you calculate it, which makes adjacent, or hypotenuse over adjacent, 5 radical 17 over 16. Does the radical simplify? No. Does the fraction simplify? No. Is there a radical in the denominator? No. There's my final answer. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. I need to use the Pythagorean theorem again. I get that my opposite side is a 6, and that makes for adjacent over opposite 8 over 6. 8 over 6 reduces, and we get 4/3. There's my final answer. So you find them for the rest of the problems on the assignment, and that is our daily work.